You can also do various illusions with your body. For instance, this famous rubber hand illusion, where you have a subject sitting in front of you, or sitting here, and then you place a rubber hand in front of the subject. So this is a rubber hand, and this is the subject's own hand. And if you then gently stroke the rubber hand and the subject's own hand, which the subject cannot see, so there is a screen here that covers the vision of the subject's own hand, so they can only see the rubber hand. So after maybe a minute or so, subjects will feel that this rubber hand is their own hand, and if you ask them if they blindfold them and ask them where is your own hand, they will point to the rubber hand and not to their own hand. You can make all sorts of various exciting illusions. There's a colleague in Stockholm who's doing a lot of these illusions. So for instance, you can actually swap bodies with a mannequin just by presenting the visual impression that you look down this mannequin. So in this case, you have a subject who has video goggles, and you stroke the subject on the stomach, but what the subject is actually seeing is the video impression from this camera on top of the mannequin. And it gives you a very strong illusion that you're in fact inside the body of this mannequin. You can also do it with swapping visual impressions. So in this case, the subject actually sees himself from this video camera, and then you stand in front of the subject and shake hands. And because you have a sensation of shaking hands and you can see a visual impression of somebody shaking hands, you will actually, after maybe a couple of minutes, switch your position of view, so you actually think that you're inside this person and you're shaking hands with yourself. They have also done some quite funny illusions where you have these video goggles on, and then you see down of a body. In this case, it's a very small, 30 centimeter long Barbie doll, and you actually think that you have this body size after a certain amount of time. So for instance, if you're stroked on your own foot while you see somebody stroking the foot of the Barbie doll. And you can test these things to see if they actually experience illusion. So for instance, if you ask subjects how long time it would take to walk a certain distance, well then they scale with that body size. So walking 5 meters as a giant that's 4 meters high, so that would probably take very short time. But if you're a Barbie doll, it would probably take, I don't know, 30 seconds or something like that. And and they have shown that you actually scale your body size to this visual impression that you get. It seems that a lot of these illusions, they involve a network that includes the parietal cortex and also the premotor cortex. So when you experience the illusion of, in this case, owning this rubber hand that's stroked, then you have increased activations of some of the premotor regions. Interestingly enough, if you, for instance, try to threaten the rubber hand, so you take a knife and try to stab the rubber hand, you will see an immediate response. So you will see increased sweating of the subject, which is experiencing this. And you will also see that areas responsible for actually coping with fear and anxiety will light up if you do scannings while you do that. So it's really an illusion that you feel strongly. Other types of illusions could be that you, in this case, it's an old illusion developed back in the 70s, where you present 3 tactile stimuli here, and then 3 tactile stimuli here. In this case, they did 6 the first place and 3 up here. And what you then experience is that you actually have tactile stimuli here in between these 2 tactile stimuli which are applied. But because this series of stimuli, maybe because you normally think that stimuli should be like continuous in some ways, you actually have an illusory sensation that something is being, or that you feel a tactile stimulus even in this area that is not stimulated. And these people from London, when they did the experiments, they actually could show that they had, at the time point when people experienced that there was tactile stimuli in this area where there wasn't any, they actually had activations of the primary somatosensory cortex in the area that wasn't stimulated really. So it seemed that there could also be some kind of top-down influence on the primary sensory areas, just as if you, for instance, attend to something in the visual field, you will see modulations in the visual areas. But in this case, if you experience this illusion as being tactile stimuli in a place that's not stroked, you will see that this primary somatosensory cortex lights up. And it seems that the premotor cortex is involved in this illusion. I think I will go briefly over some of these examples, but we have already looked at this idea of coding sensory informations, 3D objects informations into actions, and seen how this involves an area that involves the anterior parietal cortex. And some of you who are going to make a presentation next time on this experiment, so you will go further into that. Finally, if you have to make goal-directed movements and you have to do that, well, then you're guided by your perception of external stimuli. And if you then use transcranial magnetic stimulation to actually inhibit parietal areas, you will actually see that subjects become worse in doing these fast corrections. So this, of course, points towards the idea of this dorsal-ventral separation of parietal regions being responsible for processing sensory information that's necessary for actions. So, and this is a very nice example of that. So, so again, it's not like strictly clear-cut examples of purely object processing in the temporal lobe, but there seems to be at least a tendency that the temporal lobe can process very object-specific features of the external world, and features that are used for guiding actions, they are also processed in the parietal lobe. So, yes.